right, everyone, welcome aboard to our Confer Zoom. This is, I think, our third one, so I'm getting a little bit better at it, and hope you guys are getting used to it as well. I'm going to go ahead and get started with going over some announcements. And if you guys have any questions for me about anything going on in the material, go ahead and take it out as well. But before we do that, I am going to show you the announcements real quick. All right. All right. So today's meeting is going to go to around 3:30. It might finish a little bit before, but around 3:30. And again, if any of you guys need to leave early or whatnot, feel free. It's to your benefit to stay the whole time, but if you can't, I understand. It will be recorded. This is the agenda for today. I think I sent it out to you guys as well. So there will be a 10-minute break if you guys need around 2 o'clock. And then a reminder that group 3 will be presenting. I have some students doing some spotlights. I think Anthony's going to do his, Alexis is going to do hers, and a third person. So feel free to chat with me to let me know if you want to do your spotlight today. And I'll mute all of you guys in a second, but as always, you guys are always welcome to unmute yourself or chat with me if you have a question about anything. And I will be putting you guys in random breakout groups for you guys to work on things.
Do you have my student spotlight?
Anthony, can you send it to me again? I know you sent it to me on the chat, but when I closed the chat, it erased it. So can you send it to me again?
You want me to send it through the chat?
Yeah, please. You can do it privately to me.
Okay.
All right, thank you. All right, so I'm gonna put you guys in groups right now in breakout rooms. And in your breakout room, I would like you to just introduce yourself. And some of those people you might already know, some of them you might not have met yet because they were in another class. But I'd like you to share, in the midst of everything that's going on, what is something that made you smile this week? I'll share first real quick. The thing that made me smile this week was my 7-year-old son. He asked me, he's like, Mommy, when I get older and when you die, can I have your car? And I said, I was kind of shocked by that. And I said, I'm sure if my car still works by then, because I don't know when I'm going to die, right? And then he said, never mind. I'm going to sell your car and get a cooler car. So that was a double insult from a 7-year-old, but it still made me laugh. Some of the darndest things that kids say, especially when you have them 24/7 right now. So I'm going to go ahead and put you guys in your breakout groups. And let me see real quick. And introduce yourself. Okay. I think I have to stop the share real quick. Okay. Manage participants. More. How do I do breakout groups? I forgot. Breakout rooms. There you go. So there will be 5 breakout rooms. There'll be 4 to 5 people in each group. So make sure you guys give each other time to speak and share.
It was one of my dogs. They were trying to jump onto the bed, and that made me smile because they messed up.
Did they fall?
Yeah. But he got it the second time.
How about Paul? What was something that made you smile this week?
Well, me and one of my roommates just recently got into a good conversation. We both decided that we are both crazy, but we can still deal with each other just fine. So it was a good conversation. Just a difference of our personalities, but we both like each other very well. It's just it was just, you know, we're all very unique and yet still very much alike. So.
Good. It's important to live with people that you can tolerate during this time, right?
Oh yeah, yeah, definitely.
Oh, these are my kids. You want to say hi to my class? This is here. Tell them your name. What's your name?
Mommy.
And how old are you?
Mommy. 7. Can we play games on the iPad?
Yes, you can. Right now, you can. Wait, say hi to everyone.
Hi.
And how old are you?
4.
And what's something that made
No,
you
he's
smile?
5.
Oh, you're 5. What's something that made you smile this week?
That playing game.
Oh, playing games made you smile. What made you smile this week?
Playing with the Legos.
Playing Legos. All right. Okay, guys, go back outside. Love you. Okay, let's go back outside. Remember, don't interrupt me unless it's an emergency. Okay?
Good luck with that.
Yes, you can. Close the door, please.
I opened the door.
Okay. They get iPad once in a blue moon, so they get really excited that they get it once I'm doing this. Anyone else want to share with something that made you smile this week?
Finishing some of my homework made me smile.
I'm sorry, Abraham, say it again.
Finishing some of my homework made me smile.
Your homework?
Yeah.
Why did your homework make you smile?
It was stressful, and I finally turned it in. I was like, like a bunch of weight off my shoulders.
Good for you. Cool. I wish I joined one of the breakout rooms, and I said one of the things that made me smile this week was my 7-year-old. You just saw him. He said to me, "Mommy, when you get older, or when I get older, and when you die, can I have your car?" And I'm like, okay. So I said, if my car still works, sure. And then he said, never mind. I think I'll just sell your car and get a cooler car. So it was a double insult from my 7-year-old. I don't even know what he even thinks of these things, right? But I think that's what happens when you hang out with each other for so long. Like just weird thoughts come up.
It's funny. He probably doesn't even realize it's an insult. He's just like thinking out loud.
Right? Yeah. The purity of a kid. They're not trying to insult. They're just being honest. Cool. Garrett, what was something that made you smile this week?
I don't know. Probably helping. I've been working with transformations and translations with some of the students, and having them understand that is really satisfying because it's, in my mind, a really important thing to know.
Hey, good morning, guys.
Morning, Luna.
And it is tricky. And so when they understand it, it's pretty satisfying.
Good. Is that Math 45?
Yeah, Math 45.
Cool. Very cool. Alrighty, so we're gonna move forward right now, and I'm gonna go over the announcements. So I'm gonna mute you guys, and again, at any time, you guys can unmute yourselves. Mute all. Continue. All right, and I'm gonna share a screen. And alrighty, so thanks for sharing. Some announcements. I know some of you guys said that you guys couldn't access the announcements that I posted up. I'm not sure why. Sorry about that. So again, the rationals part A is due this Thursday, midnight, and part B is due on Sunday night. And we're going to be covering part B today. The next Confer Zoom is going to be next Monday at 10:10, so the time that the Math 140 normally meets. This is what to expect for next week. So next week's going to be a pretty busy week. We're going to have the quiz, which is going to be available on Monday. It'll only be available for 1 day, so it's not like last time where I gave you guys 3 days to do it. Last time it was just because it was our first time and we were all transitioning. But this time it's going to be just 1 day, and it'll be open the entire day for you to work on. The practice exam will also be available opening up this weekend, and it'll be due on Tuesday night. And again, practice exam, you can take it an unlimited number of times. The online exam itself, the big wig, is next Wednesday. So this is not something that you can do all day. It'll be something that'll be open for only 2.5 hours. You could take it any time on Wednesday, but for 2.5 hours maximum time limit. So make sure when you're taking the test, you don't have any interruptions. You have someone watching your kids or whatnot. 2.5 hour time limit anytime during that day, and it'll expire at 11:59 p.m. And it'll be the same format that you guys did in class, where you get 2 chances. The second chance is a retake of problems that you missed. Next week when we meet for Confer Zoom, group 4 will be presenting, and you have a choice of presenting either on Monday or Wednesday, so let me know. And only people who show up to it will get credit, so let me know which one works best for you guys. Confer Zoom, Monday and Wednesday, those are the times and dates and what we'll be doing. The SLA is also due next Wednesday, so hopefully you guys looked at my email done remotely, not emotely, done remotely online. See my Canvas announcement and the Math Success Center for instructions on how to do it. Paul, I think you said you've done the DLA online already. Can you share real quick how you did it?
No, I did a workshop on the 16th, which was prior to our going online. So it was my third one though.
Okay, got it. Did anyone do it on the computer already, the DLA? Not yet? Okay.
There was no link for you to click DLA. It was only like the group one
It was only the group one, huh?
that I saw.
Okay. Let me see.
Well, I think there was a link for the DLAs. When you go on the Math Success Center online, there's like, you have to go to Supplemental Learning Assistance. And then when you press read more, I believe there's like an option that you click and it takes you to the DLAs and you have to like reserve your seat and everything.
Right. Can you guys see my screenshot right now? My screen?
Yeah.
Okay. So here I clicked. So if you went to my announcement that I had here, if you click on that, this is the announcement on Canvas. If you click on that, you go here.
We can only see your week 8 announcements.
Oh, really?
Yeah, we just see your slides.
Oh, that's strange. Oh, I know why.
When you did share screen, did you only share PowerPoint?
Oh, I see. I see what I did wrong. Okay, is that better?
There we go.
Okay, so once you're on my Canvas, on the announcements, if you click on this link here, it'll take you to this page, the Math Success Center Supplemental Learning Assistance. And then you're gonna click on Math SLA schedules. Is that right, folks? This one? Oh, these are the schedules. Or let me see, DLAs. Who was it that said they already made an appointment? What did you guys do?
Basically you click on whatever time you want and then you reserve your seat.
Oh, okay. So say you want it Saturday, March 28th. Oh, here's a 12 p.m.
But is that for DLA or the group one?
Oh,
That's for DLA.
got it. And then you click on this, right?
Yeah, you just fill it out and then you come at that time and you do it.
Oh, okay, got it. And it's through Canvas Zoom?
I don't know about that.
Oh, okay,
Because I just reserved a seat. I haven't done mine yet.
got it. Okay.
Yes, it is through Canvas Zoom. I did mine for 4:45 this evening.
Okay, cool, Melanie.
Oh.
All right, so there's a Math SLA schedules. You can click on any of these and reserve a seat. Great, thank you. And there's lots of times, so that's a nice thing. Directed learning activities, nope. So make sure you click on Math SLA schedules and reserve your seat. You must sign up at least 1 hour in advance to join a workshop. And I think there's online tutoring as well on here that you could, this website isn't very clear for me. There's the workshop schedules, workshop request form. I think there's a way on here that you go on here to request online tutoring and someone could help you. But you have your own tutor, Garrett, who's available 12 to 4 p.m. Monday to Friday. So you guys could use him as well. Okay.
I really highly encourage coming on the Discord and using it.
Okay. Yeah, so here's Garrett's tutoring hours again. Here, the link I already sent to you guys on Canvas, and he's online during that time to help you guys with anything you guys need, except for the exam, right, Garrett?
Yeah, I'm not helping during the exam.
Not the exam itself, but you help out with other things. It's fine.
The practice exam, I'll gladly help you with.
Right.
Can I ask a question to Garrett?
Yes.
So we just show up anytime between 12 and 4?
Yeah, show up in time. You can take a screenshot if you have a problem, or take a picture on your phone.
Okay.
There's an app you can download on your phone, and you can just send the picture through that so I can see what problem you're working on. Or we can get into a video chat or a voice chat and talk too, however you want to do it. But yeah, you can just post
Okay.
your questions in there or ask for help.
Okay. All right. Thank you.
And I'll try and get more information about the SLA. I sent an email to Sunday, so hopefully she gets back to me and I'll let you guys know.
Great. Thanks, Garrett. All right, and just a reminder, I set up a YouTube channel with all my Confer Zoom recordings and also the lecture videos. So feel free to subscribe to it. Feel free to go on there. If you have any questions on anything, I can make videos and put it on there for you guys. On Monday, we covered Rationals Part A. We did 19 topics. This is due on Thursday. And today we're going to do Part B, which is the remaining part here, which has 29 topics, and it's a lot more challenging. So
can I interrupt for just a second?
Go for it.
Can you go back to that website?
Oh, which one?
The SLA one, the Math Success Center. Scroll up. So just go to like the Math Success Center homepage. Right there on the side. On the right-hand side, if you see it says Math Success Center, this item appears in Math Success Center. Right next to your mouse, just move your mouse up just a little bit. Math Success Center.
Okay.
Yeah, click there. Scroll down. Online resources, up, go up. Just a little bit higher, online resources. If you need to schedule an online tutoring session or sign up for statistics or math 21 tutorial, please click on that. So click on that link. And then here it tells you right at the top, tutoring is available for various math classes. Email that email address to request an online tutoring. So if you want an online tutoring, you just fill out this information.
So email msc@lbcc.edu and
Right. That's how they're doing the tutoring now. So if you want a specific time for a tutor, say I'm not available, it's out of those hours, you can do it that way. You can also email me through Canvas. And if you post in Discord, even outside of those times, there is a chance that I will see it and respond to it because I am on my computer, but just don't expect an immediate response. But during the hours of 12 to 4, you should expect an immediate response because I'm actively looking at it.
Cool.
So.
Very cool.
And
Thank you.
I'll find out about the DLAs and the SLAs.
Very cool.
Yeah, sorry, just wanted to let you guys know.
Thank you very much. All right. How do I stop the share? Stop share. Okay. Alrighty. So now I'm going to unmute you guys and I'm going to see if any of you guys have any questions on, whoops. Sorry. Any questions on any of the material from chapter 7A? Any homework questions or topic questions? Any questions? If not, speak now or forever hold your peace. All right, if not, then we're going to go ahead and go into the lecture for 7B. So hopefully at this time you guys are familiar with how do you simplify, add, or multiply and divide rationals. And today, make sure you have this worksheet, 7B, rationals. Of course, for math 130, it'll be 5B, so it's just a different number, but it'll be the same worksheet, right? So I am going to go ahead and start. I've pre-recorded a few videos because I didn't know if my kids would run in and out or not during this time. But in between the videos, I'm going to pause it. And if anytime you want to ask a question, feel free to just interrupt and I'll pause the video. But after each video, I'll pause it, give you guys a chance to do breakout rooms and participate in doing your own problems to make sure you guys understand how to do it. All right. So we're going to start off with adding and subtracting rationals. In this video, we're going to go over rationals, and specifically we're going to go over how do you add and subtract rationals. So we learned about multiplying and dividing rationals in the other video, and that's a lot easier because when the thing is, when you add or subtract fractions, you need a lowest common denominator, whereas in multiplying and dividing, you don't need to do that.
I can't hear the video.
Is that better? 7/3. Right? If we're adding fractions, we know that we can't just add as is. We need a lowest common denominator. And the lowest common denominator is going to be the lowest common multiple, right? So just think multiple. Lowest common multiple. So I asked myself, what does 4 and 3 have in common that's a multiple? So the lowest common multiple they have is the number 12. So here the LCD is 12. And what we did is we rewrote it with 12 in the denominator. And when you rewrite with 12 in the denominator, in order to change from a 4 to 12, I needed to multiply by 3. So 4 times 3 is 12, and whatever you do to the bottom, you must do to the top. So 3 times 3 is 9. Same thing to go from 3 to 12, I need to multiply by 4. So whatever I do bottom, I must do the top. That's the rules of fractions, the rules of math. I'm sorry, 4, not 14. 3 times 4 is 12, and 7 times 4 is 28. So now that I have the same denominator, then I can now add the fraction. And when I add the fraction, I keep the denominator the same, and I add the top together, 9 plus 28. And 9 plus 28 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 37. I still add with my fingers, believe it or not, 37/12. Right? And I can't simplify that anymore, so that becomes my final answer. So that's how you add fractions or subtract. You need a lowest common denominator, you rewrite the fractions with the new LCD, and you add the numerator, you keep the denominator the same. So thankfully, one of the things I love about math is that it's so consistent with its rules, because now when we're going to do that with rationals, when we're going to do adding and subtracting, it's also going to follow very similar rules as well. So let's take a look at one of the problems here. Let's look at number 4. Number 4 has c squared minus 2c all over c squared . So number 4 in your worksheet, notice that the denominators are the same. First thing I look at actually is I first look at this. I ask myself, am I adding, subtracting, multiplying, or dividing? These are eyeballs. I'm subtracting. So in my mind, I'm thinking to myself, if I'm subtracting, I need to have a lowest common denominator. This is my thought. So here, I'm looking at the denominator. Are these denominators the same? Woohoo, yes, they are. So they already have the same denominator. So I don't actually have to go through the steps of changing the denominator. So because the denominators are the same, I keep it the same here. And the top, I just simply combine the top. So the top here is c squared minus 2c minus 3. All right, now looking at the top, so ignoring this part, looking just at the top, can I simplify that anymore? I don't think I can simplify that. I can't add or subtract that to make it any smaller. And let me see. But what I can't simplify it in the sense of combining like terms, but I do notice something, that this is a square, c squared, and this is c squared. So this is a quadratic, and there's 3 terms. I'm wondering, can I factor this? Can I simplify this fraction more by factoring? So I'm thinking that, I wonder. So let's see if I could factor it. Because as we know, whenever we get a fraction, we always need to write it in simplest terms, in its lowest terms. So here, I'm going to see, can I factor this? And if I can factor it, can anything cancel out with the bottom? So looking at the top here, c squared minus 2c minus 3, if I factor that, so c times c gives me c squared. 2 things that give me 3 is 1 and 3. cross multiply, I get 3c and c. I need a negative 2c, so I'm going to subtract the negative 3 to get negative 2c. So as a result, I end up getting on top here c plus 1. So this here becomes c plus 1, c minus 3, right? Minus 3 here. Because so 1 times a negative 3 gives me a negative 3. I know I went through that kind of fast because at this point I'm assuming that you guys already know how to factor. Again, if you're struggling with factoring, please go back to my previous videos on factoring to learn how to do this. The bottom portion, can I factor this? Well, let's see. C squared plus 2c plus 1, if I look at the c squared, 2 things that multiplies give me c squared is c. 2 things that multiplies give me 1 is just 1 and 1. When I cross multiply, I get 1c and 1c. I get added together and I get 2c. Winner, winner, chicken dinner. So these are my factors. So this denominator here, c squared plus 2c plus 1, now becomes c plus 1, c plus 1. So these are all factors. These are 4 factors. And now, if I want to simplify my answer, I want to cancel out or divide out any common factors. What do you see are the same? C plus 1 and c plus 1. If I divide them by each other, I end up just getting a 1 and a 1. So my final answer, therefore, is c minus 3 over c plus 1. And please, please, please do not cancel out the c. A lot of students do that because they just go canceling happy because they just cancel things out. Remember, the c minus 3, they're attached to each other. This is like a body and its head, right? You don't detach a body from its head. You keep them together. Keep c minus 3 together, keep c plus 1 together. You can only cancel out common factors. You can't cancel out pieces of a factor. So therefore, keep the answer as is. Alrighty. So any questions on that? How do I turn the sound off? In 1 second, you turn that off. Okay? All right, so any questions on that adding fractions? All right, so let me go ahead and give you guys a chance now. Let's do some practice problems real quick. So here's I got an easel this time. I begged around and asked who has an easel, can I borrow? So here, let's look at number 1. So let's just start off with a simple problem together. Number 1, I have 1 over x plus 7 and 8 over x minus 7. So just practicing doing lowest common denominator. And go ahead and unmute yourselves. If you actually, I'll just unmute all of you guys so I could hear you guys talk. Unmute all. So looking at this problem here, if these were 2 fractions that I was adding or subtracting, what would be the lowest common denominator?
7.
I'm sorry?
7.
7? Not quite. Try again. In my video, I had walked out a little bit, but in my video, did I talk about adding fractions at different denominators?
I haven't watched it yet.
Okay, or the one that I just showed right now.
No, you
didn't. No.
I did number 4. Did I do number 10 in that video?
No.
I didn't?
No.
What happened to number 10? Okay, maybe that's why.
Hmm.
Give me 1 second. Let me take a look at this. Show number 10 as well. Oh, here it is. Subtracting fractions. Where? Sorry, give me 1 second. Let me take a look at this real quick. All right, so now I'm gonna mute you guys and I'm gonna put on another example of how do you add or subtract fractions when the denominators are different then. Did anyone have any questions on the one I just did though? No, okay, pretty simple or straightforward. So let's look at what happens when we add or subtract fractions with different denominators. All right, let's do the next problem here. Notice this is subtraction, so in my head, I'm thinking to myself that I need a lowest common denominator in order to combine two fractions. I'm looking at the denominator and I say, oh snaps, x minus 3, 5x minus 15 are not the same denominators, so that means I gotta do work. I need to find the lowest common denominator. So how do you find the lowest common denominator when it looks like this? And this is where the new thing comes along. The lowest common denominator we mentioned earlier can be considered as the lowest common multiple. But how do you find the lowest common multiple of polynomials? So another way of thinking of the lowest common denominator, it is the product of unique factors. So again, that factor word keeps showing up, of unique factors in the denominator. So it's the product of unique factors in the denominator. Very important words, product of unique factors in the denominator. So let's unpack what that means. So right now I see the word factors in the denominator. So I know I need to factor the denominator. So x minus 3, can I factor x minus 3? No. 5x minus 15, can I factor 5x minus 15? I sure can. 5x minus 15, I could pull out the greatest common factor, which is going to be a 5. So when I pull out the greatest common factor, I end up getting 5 in the denominator, and then inside I have x minus 3. So 5x minus 15 is that. Okay, so here I'm just rewriting everything. So now I factored the denominator, all right. So now this LCD is the product of unique factors in the denominator. So the LCD in this problem is going to be the product of unique factors. So what are factors in the denominator? Well, we said x minus 3 is a factor, right? You can't factor that anymore. So this in and of itself is a factor. So x minus 3 is a factor. 5 is a factor because it's being multiplied by this. And then x minus 3 again is another factor. However, notice that the word says the product of unique. So unique means that it only shows up once. So since x minus 3 already showed up as a factor here, I don't have to write x minus 3 again. It already showed up here. I don't need to write it again. So it's just 5 times x minus 3. So that is the lowest common denominator based on this definition that the LCD is the product of unique factors in the denominator. So now what do? Well, just like the problem we just did earlier, or about adding and subtracting fractions, you rewrite the problem, you rewrite the fractions with the lowest common denominator, right? So now I'm going to rewrite this. So rewrite the rationals with the LCD. So you're going to rewrite it with the LCD. So here, the denominator here is going to be 5 times x minus 3 minus 5 times x minus 3, because that's LCD. So now I'm going to change this fraction to its equivalent fraction where it has the lowest common denominator. And again, just like how we did here, to go from the old fraction to the new fraction, we ask ourselves, what do we need to multiply by? And whatever we multiply by, whatever you do the bottom, you must do the top, because that's math. You always have to keep things fair and balanced. So to go from x minus 3 to 5 times x minus 3, I need to multiply by 5, right? So I needed to multiply by 5. 5 times this whole thing will give me the denominator. So whatever I do in bottom, I must do to the top. So 5 times this whole thing. So I'm going to put this in parentheses to emphasize that I need to distribute the 5 through. So when I distribute the 5 through, I get 5x minus 5. to go from the old fraction to the new fraction, well, what do you know? It's already 5 times x minus 3. So I don't have to change anything. I just keep it as is, right? So this is a little bit less work for me because it was already the same. Now that I have the lowest common denominator, now I can combine the fractions. Now I can subtract them because I have the lowest common denominator. Just like this problem here, once you have the lowest common denominator, you can add or subtract the numerators. So here, when I combine the fractions, I have 5 times x minus 3 in the denominator. The numerator, I have 5x minus 5 minus, and I'm going to do something incorrect, and I want you to catch it, minus 2x plus 4. I'll give you a second to see what in the world did Professor Mahan do incorrect.
Plus 4.
Hope you guys caught it. The minus sign is outside of this whole fraction, so the minus sign is applied to everything here, so I need to actually distribute the minus sign through. So minus this 2x becomes a negative 2x, and this positive 4 should become a negative 4. So you need to distribute the negative sign in order to have the correct answer. So here, I did that. And just to remind you of the previous problem where we had the minus sign here, minus 3, it was only just one number here, so we didn't have to distribute it through to anything. We just applied it to the 3, so it became a negative 3. But here in this problem, since there's 2 terms, you need to distribute it through to both of those terms. All right, so now that I have that, before we try to cancel anything, let's just look at the numerator and let's simplify the numerator. Can I combine any of these terms? Are any of them like terms or like animals, as we would say in class? 5x minus 2x will give me 3x. Negative 5 minus 4 will give me negative 9. In the bottom here, I have 5 times x minus 3. Phew, all that work, and we think we're done, right? We think we're done, but no, no, no. Do not think you're done yet, because whenever you end up with a fraction, make sure your fraction is in lowest simplified term. So I look at the top and I ask myself, can I factor it? So the next part is simplify the fraction by factoring. So again, factoring comes up again. Did I not mention that factoring is so important? So here, 3x minus 9, can I factor that? I sure can. I could pull out the 3, which is the greatest common factor, and inside of x minus 3, because 3x minus 9. In the bottom here, I have 5 times x minus 3. Factor, 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 factor. Are there any common factors in this answer? X minus 3, x minus 3. X minus 3 divided by x minus 3 would just give me 1. So therefore, my answer is, sorry about this part, my answer is 3 over 5. Isn't that beautiful? Something that started off so messy becomes so pretty at the end. Hence the beauty of math. Alrighty, so there you have it. That's how you add and subtract with denominators that are not the same. Does anyone have any questions on the problem that I can help you with?
I do.
Mm-hmm.
Can't you where it says the 2x plus 4, couldn't you factor that out?
The 2x plus 4, let me grab that sheet of paper that I was working on. Actually, I saved it. Actually, the 2x plus 4. Just
Yeah.
All the way at the end, you mean? Here, 3x.
Kind of in the beginning where you were multiplying the first fraction with 5.
Let me see real quick.
Yeah,
right here?
yeah, right there. Can you just have it as 2 parentheses x plus 2?
Right, you could. Let me see. So You could do that, but then there's really no point of factoring. So the question is that we really want to ask is, why do we want to factor? Most of the time we don't want to factor. We actually want to distribute and get rid of parentheses. So we only factor when there's a reason to factor. So that's a great question. So why don't we factor this guy? It's because there's really no reason to factor it. The only reason why we want to factor is 1, to find the lowest common denominator, or 2, at the end to cancel out or to simplify the fraction. So here, if I did write this as 2 times x plus 2, I'm going to end up having to, so when I keep going here, when we end up going to this part, if I factored it out, 2 times x plus 2, I'm still going to have to distribute it and go back to 2x plus negative 2x plus 4. Does that make sense?
Oh, okay, yeah. I
Right.
got it.
In the end, you're going to have to multiply it all out anyways, right?
Okay.
Good question. Yeah, so really be careful of when you factor, what the purpose is for factoring. The purpose of factoring, 1, is to find the lowest common denominator, and 2, to simplify your answer at the end. But most of the time, there really is no other reason to factor. You actually want to get rid of parentheses of anything. Great question. All right, any other questions on that problem? No such thing as a bad question. All right, if not, I'm going to move forward with, let's look at number 1. So now we're going to slow things down a little bit. I know it kind of just went from problem to problem, but let's just do some exercise of finding the lowest common denominator. So this isn't adding or subtracting number 1, it's just saying find the lowest common denominator. And we said in the video that the LCD is the product of unique factors in the denominator. Right? So that being said, if you had these 2 fractions, so anyone can answer at this point, or I'll call on someone, doesn't matter. What would be the LCD of this problem?
Wouldn't it be x plus 7, x minus 7?
Right, x plus 7, x minus 7. Good. That's LCD. Okay. And how did you get that? Or how did you know that?
You said the LCD's products of unique factors, and they're both unique. They're not the same because it has addition and subtraction.
Right. Nice. They're both different. They're not the same. So you just write them both down, and they're already factored, right, as is. Great. Let's look at number 2. So go ahead and look at number 2. So it's not as obvious now, right? So the LCD is the product of unique factors in the denominator. First thing you have to do is factor them.
X minus 2.
Okay. 7 times x minus 2, great.
And the other one, 3, x minus 2.
3x minus 2. Okay. Good. So if we factor it first, so now that we factored it, what would the LCD be then?
X minus 2.
So x minus 2, right? So these are the factors. So we only write it once because it has to be unique. And what else? We have 7 and 3. What's the lowest common denominator of 7 and 3?
Do you multiply them?
Good. And what would that give you?
21.
21, right? So again, the lowest common denominator, if you just look at 7 and 3, the lowest common denominator is the lowest common multiple. So the lowest common multiple of 7 and 3 is 21, or you could think of just multiplying these two to give you 21, right? Great. Now let's look at number 3. Let me give you guys a chance to do number 3. So go ahead and just do this on your paper. I'll give you guys a chance to do this. And you guys have it on your, you guys have it in front of you, or you could just copy down what I have on the board if you haven't printed out the worksheet. Let me give you guys a chance to do this. So remember that you need to factor each one, and then the lowest common denominator is the product of unique factors in the denominator. I'm sorry, Suzette, can you say it again? You got x plus 2
And x plus 5.
and x plus 5. All right. And then?
And then for the next one, I got x parentheses x plus 5.
Okay, x parentheses x plus 5. All right, great. So does anyone have any questions with what Suzette did with factoring the denominator? All right, so keep going. So what would the LCD be, Suzette, of these?
X plus 5.
All right.
And that's all I got.
Good. Well, so remember that LCD is the product of unique factors in the denominator. So you did the hard part, which is to factor it. Now you just need to write it all out, right? So you got x plus 5. What else is a factor?
X plus 2.
Right, x plus 2. So we're going to write x plus 2. So product, meaning you write it next to each other. So we took care of this. We took care of this. What else here?
The x.
Great, the x. So the x needs to also be part of this as well, right? Do we need to write x plus 5 again?
No.
No, right? Because it's not unique. It already occurred once, so we don't have to write it again. So the LCD then would be this whole shebang. Okay? Any questions on that? All right, nice work, folks. Now let's go ahead. So we did 1, 2, 3. The video we did 4. I'm gonna just do something a little bit, and we did number 10 on the video. Let's go ahead and do one as a class together that's a little bit trickier. So how about number, what number? How about number 9? Okay, so unless any of you guys see anything on there that you're like, I hope she does this, I hope she does this. Let's look at number 9. So number 9 here, again, if you don't have your worksheet, I'll write it on top. It's a plus sign. All right, so looking at this problem, I see subtraction signs, so I think to myself, I need to have a lowest common denominator. If it's multiplying or dividing, I don't even have to worry about it. But because I see the subtraction sign, I think lowest common denominator. So lowest common denominator is the product of unique factors in the denominator. Are these already factored?
Yes.
Yep, so they're already factored, so I don't have to do much work, right? So what would the LCD be?
X times x plus 5 in parentheses.
Okay, x times x plus 5 in parentheses, okay? Is everyone okay with what Felicita just did? Right, perfect. So now we're gonna have to rewrite the fractions with the LCD. So I'm gonna rewrite it with the LCD, x times x plus 5 minus x times x plus 5. And the powerful thing about math is that you can change a fraction to its equivalent fraction. You're very powerful to do that, but as long as you follow the rules. And the rules is whatever you multiply on the bottom, you must multiply on top. So here, to go from x plus 5 to the new one, what did I have to multiply by?
X.
X, right? I needed to multiply by x in order to get x times x plus 5. Whatever you do bottom, you do to the top, right? And then whatever you do to the top, you have to distribute it through, right? So on top, I get
X squared.
X squared plus 9x.
x squared plus 9x, right? Any questions? Second fraction, to go from the old fraction to the new fraction, what do I need to multiply by?
X plus 5.
Right, x plus 5. Whatever I do bottom, I must do to the top, right? And here, I need to multiply this whole blue thing with this whole green thing. So I put it in parentheses. And if you multiply through, what do we get? It's a little bit harder, but it's still doable.
X squared plus 2x minus 15.
X squared plus 2x minus 15, great. And Abraham did that by foiling, right? X squared plus 5x minus 3x. So 5x minus 3x gives you 2x minus 15. Any questions with the foiling part? Alrighty, so now that we have that, so now that we have two fractions with the same denominator, now I can combine them. And when you combine them, remember, you keep the bottom the same, right? So it's a similar story to how do you combine like terms. You keep the animal the same. You keep the part that's like, which is its denominator, you keep that the same, and then you add its coefficients, right? So go ahead and combine them. What do you think about what I wrote?
You didn't distribute the negative.
Right, good job, Felicita. So I didn't distribute the negative. So again, very common mistake that students make. They put the minus sign in the first one, but they forget to distribute the minus sign. Great. So what changes if I distribute the minus sign?
It's a negative 2x and a positive 15.
Great. Negative 2x and positive 15. Is everyone okay with that? Any questions? So make sure you distribute the minus sign. Okay. And what do I do after this? Do I cancel things out?
Like terms.
Okay. Combine like terms, right? So at this point, please do not cancel things out. Again, students are always, I see this a lot where people want to cancel things out very, very quickly, but please don't cancel things out until they're fully factored. So make sure you combine like terms. Make the top pretty first, right? Make the top pretty, and then you can factor and then cancel things out. So let me give you a chance to go ahead and make the top pretty, meaning combine like terms at top. Anthony, are you there? Can you help me out? What did you get on top?
Which one?
For this one right here, what did you get on top, Anthony? The green part.
Oh, I haven't finished.
Okay.
Would it be 7x plus 15?
Great. So the x squared cancels out. Great. 9x minus 2x is 7x plus 15. Great. The bottom is x times x plus 5. Right?
Yeah.
Question for you guys. Can I cancel the x and the x here?
No.
Can I cancel the 15 and the 5?
No.
No, right? Why not? Why can't I cancel things out?
Because
they both have to be 7x for you to cancel them out.
Right. They both have to be the exact same factors, right? So you can only cancel out factors. 7x plus 15, can I factor that anymore?
No.
No. So therefore, this whole thing's a factor, right? X times x plus 5, these are already factored. So factor and factor. So I like to circle things to say, okay, this is the whole factor, right? We cannot chop up the factor. It stays as is. So I can't say, oh, this x and this x, I'm going to cancel them. You can't do that. It stays as itself. So therefore, this answer is final. Any questions for that? Is that doable?
Yeah.
Yep. Coolio, Julio. All right, let's go ahead and look at your worksheet. I'm gonna have you guys work on a problem. Number 12. Number 12 is probably the hardest one in this worksheet. Work on number 12. I'll write it on the board here if you guys don't have your worksheet. I'll give you guys a few minutes to work on it, and then I'm gonna put you guys into breakout rooms, and you guys can ask each other questions, compare answers, or whatnot. All right, so for those of you guys that might not have the problem on hand, here it is. Feel free to copy it down, and in a second, I'll go ahead and work on it, and I'll put you guys in breakout rooms. So let's get back to this. Let me just, there you go. So anyone, what did you guys get when you guys found the lowest or the, when you factored this?
X plus 3
X plus 3
and
times
3x minus 5.
3x minus 5. Do you guys agree with Felicita?
Yes.
Yes.
Great. Any questions? All right, let's go ahead and factor this guy. What did you guys get when you factored this guy?
3x minus
I'm sorry, 3x what?
5.
5.
X minus 4. 3x minus 5.
And x minus 4?
Yeah.
You guys agree?
Yes.
Does anyone have questions with how we got those? Anyone have any questions? Need that to be worked out. All right. If not, then let's go ahead and talk about what is the LCD. So let me just call on random people. How about David? Are you there? David, you there? No? How about Jade? Are you there? Jade, can you help me out? How come I see people's names on here, but no one's saying anything? Jeez. Okay, that's like something that should go in America's Funniest Home Video. All right. The problems of teaching online at home. Hold on 1 second. I'm so glad my kids weren't standing right there. It's kind of a wobbly thingamajigger. All right, so Jennifer, are you there?
Yeah.
Can you tell me what the LCD is going to be?
It'll be 3x minus 5
All right,
times parentheses x plus 3,
all right,
and then x minus 4.
and then x minus 4. All right, great. Does everyone agree with Jennifer?
Yes.
Yes.
Awesome. So let's go ahead and rewrite this fraction with the lowest common denominator. So here, I'm going to rewrite these fractions with the LCD. Then plus so now we have with the LCD. Sophia, are you there?
Yes.
All right, Sophia. So to go from the old fraction to the new fraction, what do I need to multiply to go from the old to the new? Here's the old. Sorry.
The LCD.
So to go from the old fraction to the new fraction, I have x plus 3 and I have 3x minus 5. But what am I missing? I'm actually pointing to it.
X minus 4.
Okay. So we're missing an x minus 4. Do you see that from the old to the new? We're missing the x minus 4. So I need to multiply by x minus 4 in the bottom. And
So
whatever.
we have to multiply it on the top.
Yes, we must multiply on the top. Great. So if I multiply on the top, what do I get on the numerator here?
2x minus 4.
2x
Or minus 8.
Good. 2x minus 8. So good job doing that. And Sophia, I'm just going to keep you online for a little bit more. To go from the old fraction to the new fraction of this one, what do I need to multiply by?
X minus 4.
Try that. So I already have x minus 4 is already here. What's missing from the old to the new fraction?
Oh, x plus 3.
Yeah, we're missing the x plus 3. So what do we need to do on top?
Multiply.
Right, by x plus 3. Good. So on top here, what's 1 times x plus 3?
1x plus 3.
Right, or just x plus 3, right? Okay, okay, great job with what Sophia did.
Yes.
All right, awesome. So let's keep moving forward. So Ashley, are you on?
Yeah.
Okay. Ashley, what do we do next?
I don't know how to explain it. Like we move it like together.
Okay, we put it together. So we're gonna combine both fractions. Oops. So I'm gonna keep the denominator the same. I combine both fractions. And then what do you get on top when you combine the tops?
2x minus 8 plus x plus 3.
2x minus 8 plus x plus 3. Great. And then what do you do after that, Ashley?
You combine it.
Okay. And when you combine it, what do you get?
3x minus 5.
Okay, so 3x minus 5 on top. Everyone okay with that? Okay. So on the bottom here, we have 3x minus 5, x plus 3, x minus 4. Right? So what do we do next?
We cancel out whatever is the same.
Right? And what is the same, Ashley?
3x minus 5.
Great. So the top and the bottom have the common factors 3x minus 5. So if I cancel this out and this out, they cancel out. And what is in the place of the numerator now?
1.
Just 1. Right. So make sure you put a 1 there, and this thing keeps falling. So my final answer is going to be 1 over x plus 3 times x minus 4. Right. That's going to be your final answer, and you do not need to multiply through, you just leave it as is. Great job. Any questions on this problem? This is the hardest problem for adding or subtracting rationals. So if you understand this, you're in good shape for doing the rest of the problems. Any questions?
Oh my God.
Okay, Nancy. Does anyone want to buy me a new easel?
No. Fusion, no. They cannot go there. It's only for the link box. Oh, okay.
All right. Great job. Are there any other questions about adding or subtracting rationals up to the number 12 that you're like dying for me to do? Or are you guys okay?
Number 8.
Number 8, okay. So Ashley asked about number 8. I'm so afraid of touching this thing right now. Let me get an eraser. It fell down into La La Land. Oh, here it is. Okay.
What's going on? I'm just cheating on it.
All right. So number 8 here. I'm going to try to pull it closer. Try to keep it on the carpet so it doesn't fall. Okay, so Ashley asked about number 8. All right, so this looks a little bit different from what we've done, but it's actually exactly very much the same. So what I'm gonna do is, I notice, okay, it's subtraction. So in my mind, I'm thinking I need an LCD. So here the LCD is a product of unique factors in the denominator. Well, these are all factors already. Factors, again, are things that are being multiplied with each other. So 8a, k, 4, c cubed, k squared, those are all factors, right? So I don't have to factor anything. They're already factored. So I look at the number 8 and 4, and I say, what's the lowest common denominator of 8 and 4? Anyone?
2.
So the lowest,
Oh, wait, no. Sorry.
so they have the lowest common multiple. What does 8 and 4 have in common as the lowest common multiple?
4.
Not 4, but...
Oh, 2.
So when you think lowest common multiple, think of multiplication, right? So what do they both have in common that's a multiple of each other?
8.
8, right?
There you go.
So it's kind of confusing because sometimes when we think of factors, when we think of factors, we think of what are they both divisible by? But remember, lowest common denominator is what common multiple do they have in common, right? So what multiple is 8 and 4 has a multiple of 8 in common. So, and then I have A. Well, this one doesn't have an A. So again, the lowest common denominator is the product of unique factors. So A is a factor. K is a factor. Well, I have a K and a k squared, right? So again, so here the k and the k squared, between this one and this one, I say what multiple do they have in common? So the k and k squared, you pick the one that's bigger, right? Because what multiple do they have in common? So k squared, right? And then the c cubed right here. And technically, maybe I should write it in alphabetical order just to, and you don't have to, but I'm just writing in alphabetical order, right? So 8 is the lowest common multiple. C cubed, because there's nothing there, so product of unique factors. And then k and k squared, the lowest common multiple is k squared, right? So we're thinking about lowest common denominator as opposites of when we're trying to find the factor of something, okay? So that is a little bit more trickier. So now I'm going to rewrite this with the lowest common denominator. So I have 8ac cubed k squared minus 8ac cubed k squared. So again, thinking of the lowest common multiple or the product of unique factors. So I'm going to ask myself to go from the old to the new, to go from the old fraction to the new fraction, what's missing?
C cubed and a k.
C cubed is missing, good. And then a k is missing because here's a k and here's a k squared, so you need another k. Good job, Felicita. So whatever we do bottom, we do to the top. So we multiply this by the top. So what do we end up getting? C to the...
C to the fourth.
Good.
K and then x.
Great. Is everyone okay with what Felicita just did?
Yeah.
The second fraction, to go from this old fraction to the new fraction, what do I need to multiply by? 2. And what else?
A.
2a, good job. Anything else? That's it, right? Because it already has a c cubed and it already has a k squared. Whatever we do bottom, we do to the top. So what do we get on the top?
6aw cubed.
6aw squared, actually. Yeah, this is a square.
Squared.
Yeah, the squared. Did I write that down right?
I think it's cubed.
Oh, it's cubed. Just kidding. My bad. Thank you. Thanks for correcting me. So this is a cube, and so therefore this is a cube, right? So the problem had cubed in it. Right. Is everyone okay so far? All right, so now I'm going to combine both fractions. I'm going to keep the animal the same. In other words, I'm going to keep the denominator the same. The top, I'm just going to subtract the top together. So I have C4kx minus 6aw cubed. Right? And then I ask myself, well, can I simplify this fraction? In other words, is there anything here and here that is common factor that can pull out?
No.
No.
Anything the same? They have nothing the same, right? So this is C, this is A, K, X, W, nothing the same. So therefore, since there's nothing that's the same, I can't simplify it. So please do not go, oh, K, cancel, cancel. Oh, W, cancel. Don't cancel things unless you factor it out first. So since you can't factor it out anymore, then this would be the final, then you can't cancel anything out. So that would be the final answer. Okay, any questions on that? Alrighty, I'm glad you asked about that problem. So you'll have many examples to go through in here. We're going to go ahead and go into complex fractions now. So complex fractions is covered in number 13 all the way to number 20. So there's 1, 2, 3, 4, 5, 6. So there's 8 questions on complex fractions. So I'm going to show you guys a video that I already made on complex fractions, but I do want to say that there are many different ways of approaching complex fractions, but I'm going to teach you my favorite way. And the reason why it's my favorite way is because it's really, it glides smoothly into the last section, which is on equations. You're going to do exactly the same thing with what you did with complex with equations. But again, just warning you, on Alex is going to teach you a different way. Maybe when you go to Math Success Center, they'll teach you a different way. But the way that I teach is going to be true for all problems, whether they're easy or hard. So I'm going to mute you guys, and I'm going to turn on the video. Share screen, video. In the world did Professor Mahan do in, not that one, sorry. Oops. Hi, this is Professor Nancy Mahan. In this video, we're going to be talking about complex rationals. So what are complex rationals? Well, the word complex means it's complicated. It's not simple, right? And rationals, again, are fractions with polynomials in it. So here's an example of a complex rational. So complex rational is, if you've noticed, it's a fraction within a fraction. Here's the big fraction, and then there's little fractions on top and on bottom. So it's fractions, I would just say it's fractions within another fraction. So it's complicated looking fractions, right? So here, a fraction here and a fraction here, and it's divided by each other. So a fraction divided by another fraction. So there are several ways of doing this problem. I'm going to show you my way of doing it. And again, there's several different ways. And if you like the way that you see it in Alex or from another teacher or tutor, do whatever floats your boat. But I'm going to show you my way because the way that I'm going to teach you it is how we deal with complex rationals is going to be the exact same way with how we deal with solving rational equations. So the next topic is solving rational equations, and it's going to be very similar to the steps I'm going to take for simplifying complex rationals. So here, step 1, I am going to find the lowest common denominator of the two small, quote unquote, small fractions. Right? The small fractions meaning here's a small fraction and here's another small fraction. And then there's the big fraction, right? There's the big fraction out here. So find the lowest common denominator of the two small fractions. So here I have 2 and here I have 12w. So in this problem, the LCD, 2 and 12w, the lowest common denominator is the lowest common multiple. What multiple does 2 and 12 have in common? 12. So 12 and then multiple w. So the lowest common denominator is 12w. So what are we going to do with this LCD? So just like when we deal with equations, which we will be doing next, we are going to use the LCD and we're going to get rid of quote unquote small fractions. So we want to get rid of the small looking fractions by multiplying the numerator, or the top, and the denominator, or the bottom, by the LCD. I hope that sounds familiar to you because when we were dealing with equations, in order to get rid of fractions in equation, we multiply the equation by the LCD. In this case, since it's not an equation, but there's just one big fraction here, we're going to multiply the top and the bottom by the LCD to get rid of the small fractions. So let's see how that looks like. So here I'm going to multiply everything by 12w. So 12w goes on top when you multiply, and I multiply by 12w here. So 12w is in the numerator, right? When you're multiplying it through. So here I'm going to multiply by 12w, and look what's going to happen. So if you chose the right LCD, 12 divided by 2 gives me 6. So this here cancels out, and I end up getting a 6 on top, and that just becomes a 1, right? So when I multiply the top, I get w minus 3 times 6w. So w minus 3 times 6w. That's the top. Now the bottom, what cancels out? Well, look at this. The 12w and 12w cancels out, just become a 1. Comes a 1. And what's left on the denominator? I have a w squared minus 6w plus 9. No more little fractions. Now we're only left with a big fraction, and that's what we want, right? So that makes me happy because now it's no longer complex looking, it's simple. It's just a simple fraction now. So now let's go ahead and step 3. Now that you just have one simple fraction, go ahead and continue to simplify the fraction as we've been doing earlier, right? So let's just simplify this. So I need to multiply this through. So when I multiply this through, I get 6w squared minus 18w. Oh, maybe I should just left as such. But anyways, and then I have w squared minus 6w plus 9. So I have this when I multiply through, I got that. And I'm like, oh, wait a minute. Maybe I should factor this, because to simplify a fraction, I should factor it. Okay, well, let's factor it. Well, 6w squared minus 18w, whoops, it's already factored up here, so I'm just doing double work. My bad. So I'm going to factor out the 6w. And then inside, I have w minus 3. So I just kind of did that, then did that, then did that. So I just went back to its home base, right? And then the denominator, I'm going to try to factor the denominator using xbox. So again, I'm going to do xbox on the side here. Two numbers that multiply to give me w squared, or w and w. Two numbers that multiply to give me 9, or 3 and 3. Cross multiply, I get 3w, 3w. I want a negative 6w, so I have a negative and a negative there. Winner, winner, chicken dinner. I want a negative and a negative. And indeed, a negative 3 times a negative 3 gives me a positive 9. So therefore, these are my numbers on the bottom. W minus 3 times W minus 3. Now I can say, oh, can I cancel any common factors in the bottom and the top and the bottom? Well, what do you know? W minus 3 divided by W minus 3 would just give me 1. So now I am left with 6W over W minus 3. And that becomes my final answer. And again, please, please, please do not cancel the W out, right? Because this is a whole factor. This is a whole factor. You cannot cut a head from a body, right? So you can't just take out the W here and take out this. They all come together. So you leave it as is. All righty. Let me get out of that. All right, does anyone have any questions on that? Any questions? All right, so I created another video as well to do this, but I want you guys to go ahead and I'm gonna give you guys a break. And if you would like during your break, you can work on this problem and then I'll show the video after that. But you guys try it out. It's gonna be number 19. So I tried to pick a harder problem this time. So number 19. So that's the top fraction. And then the bottom fraction is this. Okay, so again, if you don't have your worksheet, it's right there. I'm gonna give you guys, so if you want, you could work on that during the break if you like, or if you want, you could just take a break. I'm gonna give us a 10-minute break. It's 2:35 right now. At 2:45, we'll come back on. You can work on that, or you can just take a break, and then when we come back, I'll show you guys how to do that. Okay, so now we're gonna go back and we're gonna do some student spotlights, and then we'll have a group 3 presentation. So let me go ahead and share a screen. Alexis, are you there? Alexis? All right, if not, we're gonna start off with Anthony sharing. Let me go ahead and make this bigger. Quick. All right, Anthony, you're on.
I'm Anthony Miranda. The picture I have in the background is when I was in Turks and Caicos. That's my brother is in the middle, my sister's on the right. My dad's next to my brother and my mom's on the far left. On the top left corner is a picture of my baby nephew. He's 7 months. On the top right is just another picture of my entire family. On the bottom left, that's a poster because I had leukemia. So I just finished treatment last last May, and the two pictures in the middle are I went to a Laker game like 2014. I went to go see Kobe, but he was injured. And then my Barcelona, I'm a huge Barcelona fan. And then my bottom right is a picture of my graduation. Like I didn't have any hair there because that's when I was still going through treatment. So I was a senior, so like I literally graduated after I got out the hospital. Like my graduation was on a Saturday, so I got out that Friday, and then the next morning I had to show up just to graduate. But that's basically it.
Wow. Any questions for Anthony? Well, I have a question for you, Anthony. What was it like for you to go through leukemia and to come out of it?
It was pretty hard.
Do you feel like it's changed you in any way, or?
Yeah, I feel it has, but like I don't know. It's like changed a lot, like my perspective, like to be more humble in life and to be more grateful.
Wow. How long did you have it for before you had your treatment?
I got diagnosed the second half of my semester, but they caught it early, so like my entire treatment lasted since January 21st, 2016 to May 23rd, 2019. So
Wow.
like 3.5 years.
Wow. And are you completely healed from it, or is it still?
Yeah, I am, but like I still have like some, like I almost went blind. Like because I was like I'm susceptible to illnesses. So like I went back to school during treatment. Like I was in college taking classes.
No, I don't want to like pictures.
I was in classes, but I got sick, so like I went to the hospital I had to drop my classes and I got incomplete. So this is why I'm retaking Math 130 because I had to get incomplete for it. So I was in the hospital and I had a virus, I had pneumonia, and then like I had a stomach bacteria. So yeah, I'm still going through that.
Wow. Well, thank you so much for sharing that, Anthony. I mean, I always really respect and admire people who've gone through health issues, and gives you a different perspective of life too.
Yeah.
Thank you. You are very brave, as that picture says.
Oh, and that's also makes sense because like I went to St. John Bosco and like we're considered the Braves.
Oh, so the double meaning.
Yeah.
Anyone else have any questions for Anthony? Alrighty, thank you, Anthony.
Yeah.
And who was the other person that said that they wanted to share? I forgot. Okay. I'm sorry, was it Diana that said that you had your PowerPoint ready?
Yes.
Okay, do you have it on your screen by any chance, or do you want me to pull it up?
No, I don't have it.
You don't have it? Okay, let me go ahead and pull it up real quick. And you said you Facebook messaged it to me?
Yes.
Okay, I found it, Diana Contreras. Alrighty, let me pull it up right now, and I'm gonna share screen. Alexis, are you here by any chance? No? Okay. All right, sharing screen. And now. All right, Diana, you're on. Diana, you there?
Yes.
Yeah, go ahead and share about what you have up here?
Okay, so my name is Diana Contreras. Start off the top right corner. That's a picture that I pulled from Google. It was like, my major is child development, and I want to become a preschool teacher in the future. And then under that, there's a picture of the 3 girls. I'm the one in the middle, and then the 2 girls next to me, they're my best friends from since kinder, and the other one since 1st grade. And then the picture, 3 guys, those they're my oldest, the two of my older brothers, and then my youngest brother. I'm the only girl. And then the dog, the pictures of the dogs in the middle, it's the same dog, and that's my baby. I've had him for 3 years now. The picture at the bottom with like the mountains, that's a picture where my parents are from in Mexico, and they're from Jalisco, and I really like going to Mexico. I love Mexico. And the picture in the red dress, that's a picture of me. I was at a show, I was performing. I'm a dancer. I've been dancing for about 9 years now. And the one next to it at the top left corner, it's a picture of like some girls working out because I like to go to the gym. I like to work out. And then under that, the picture with the flag, it's my dance teacher and my the other people that dance with me. Yeah, they started dancing for like 9 years as well. We grew together, and then that was actually at a competition in Barcelona. We went to represent, and yeah, it was really fun. And then just more dance pictures at the bottom. Yeah, that's about it.
Very cool. Are you a dance major?
No, child development.
Oh, child development. Okay. Very cool. Any questions for Diana?
I have a question. What do you want to do with your childhood development major? Is there a certain grade you want to teach, or
preschool?
Preschool? Awesome. What's your favorite like age?
Well, I like
working with kids.
5-year-olds preferably.
The 5-year-olds. Right on.
Do you want to babysit my kids, Diana? They're 5 and 7. They're driving me crazy. Just kidding. Very cool. Well, thank you so much.
My brother is 17, but you could take care of him too.
Oh no.
That's funny. Everyone bring your kids over to Diana's house. You can have free internship right now. That's awesome. Well, it takes someone with a really big heart to really enjoy teaching kids. So kudos. And maybe you could teach them dance too. All right, thank you, Diana. Thank you, Diana. Can you guys see this next PowerPoint? Can you guys see this? So Diana, Brianna, Angelica, and Jennifer, come on forward. You guys are presenting for your group today. Who's here today? No, Diana's here. Who else is here?
I'm here. Angelica's here.
Bree's here.
Great. So so Angelica's here, Bree is here, Diana, is Jennifer here? No Jennifer?
She was here. Just give her a second. She was here earlier.
Okay. And who was the other group? There's one more, Stephanie and Paloma's group. Do you guys have your stuff ready to present as well?
Yeah, I emailed it to you.
You emailed it to me? Okay. Is it just you, Paloma, or is your group?
No, Stephanie and Vincent is here.
Vincent is in your group?
Yeah.
And Stephanie is in your group?
Yes.
Yeah.
So it's the 3 of you guys are presenting?
Yes, ma'am.
Okay. Let me check with this group. Jennifer, are you here yet?
Yeah, it's because you were freezing online. I was like, I couldn't hear you. I couldn't hear you guys talking. I just could hear like you guys were freezing, but I could hear you guys now well.
Okay, that's Jennifer, right?
Yeah.
Okay, great. So why don't you guys go ahead and go first?
Okay.
Let me know when you want me to change the thing. Or,
Oh yeah. Sorry.
you ready?
Yes.
Okay, go for it. Hello? Group 3?
You go ahead and change it. Thank you. I'll just.
You
want me to share it?
Do you guys want to share it from your screen? Why don't you share it from your screen so that way you guys can control it?
Yeah.
I don't know how to.
Can you see it, Professor?
Nope. Are you pressing share screen?
Yeah, I pressed share screen and it says either to deny or let it, and I put. Let me try it again.
How do you share a screen?
Yeah, I've been trying. Let me see.
There's a button on the bottom that says share screen. And then when you click on it, you'll there see yeah, Garrett just shared a screen.
I'm pressing share and it does not. Because mine it says share screen and put entry screen, application window, or Chrome tab.
Do you have a desktop that you can share from?
Oh, okay, got it. I think I got it. Did it do it?
Or anyone from your group can share the screen, whoever.
Hold on, I'm trying to do it as well.
Maybe because we're all trying at the same time.
I don't see it.
Is it working? If not, I'll just share from my screen. Do you want me to share from my screen?
Yeah.
Okay. Because I have your PowerPoint.
Yeah, just because I tried it.
Oops, not this one. All right, why don't you guys go ahead and start talking, and then I'll turn the page accordingly.
Mommy?
All right, are you guys ready?
Okay.
Yes.
So when is math being applied? We apply math everywhere in our daily life, however, we may not notice it as often. For example, in our using money, how buildings are created, gas prices, time, baking, and etc. Okay, next.
Okay, so our topic was, we chose to do it on coordinate points. So the way we apply coordinates is by using them to locate. So for example, airplanes, boats, submarines, cars, and even when we're using Google Maps. Next.
So then this is an example of how to use a point. Usually it could be in decimals and stuff like that, but we have 1 point would be 2 comma 3, which you could see is 2, and then use X is 2, and then 3 is Y. There's 1 point is green, and then 6 comma 2, and then 6 and 2. So that's an example. And then the next one would be an example for you guys to do as a class.
Okay, for the class project, we will have the graphing points. You have 2 comma 3. So we find 2 and we run all the way up to 3.
no, rise to 3, and then we have 3 comma 4, and then we run to 3, and then rise up to 4, and then we have 5 comma 6. We run to 4 and run to 5, rise to 6, and then 6 comma 8, run to 6 and rise 8. And the next slide will show you your answers.
Alrighty. Are you guys finished?
Yes.
Yes.
Okay, great. So those are applications of how math is being applied: money, buildings, cash prices, time, baking, etc. So those are some coordinate systems, especially us being such a global economy, as you've seen, and everything's being affected globally. One of the things we do is that we use coordinates as a global nation as well. Okay, great. Thank you, ladies, 4 ladies. Okay, and I'm gonna group 3, Stephanie, Paloma, Vincent. Was it you guys?
Yes.
And where did you say that you emailed it to me?
Through Gmail, but I can definitely screen share.
Yeah, why don't you share on screen share?
You guys want that? Okay, well, mine as well. Let's see. I don't know if you guys can see it.
Yep, we can see it.
Definitely. Let's see. All right. Hey guys, we're group 3. Let's see. Okay, Stephanie.
Okay. So we all know that math is like in every store where you go, such as like Forever 21, Hot Topic, anything like that. We all know that like everyone loves having sales and deals because that's the way people love saving money. And then we all know like how will you know how much would it be when he has like, for example, like 50% off. So I recognize these formula that we learned in class. So what you do in order to find the new price is you get the sales, is such as it's 50% off, and you multiply it by the regular price, which you get the total. And then once you have the total, you get the regular price, subtract it with the total, and you will get the new price. And then we all know that with math, it involves when people are building houses or buildings. They use it to analyze and calculate problems in order to engineer a solution that it will help the building remain standing and stable. And they also use shapes and sizes of the elements. Next slide.
Math in sports. So in football, we use math constantly because it's really a game of numbers. You have 4 downs, so those kind of work as sets. For every down, however much yardage you have left to gain, that tells you what kind of plays you're allowed to run. So math is really a big part of the game. In basketball, you need to be able to accurately estimate angles and arcs if you want to make shots or get rebounds or get steals. It requires you to have like a solid grasp of geometry. And then as every big sports fan knows, the most important thing in sports is money. That funds everything. So obviously math is a huge part of money. And then finally, counting and sets are used in almost every athlete's workouts. If you want to train, you have to have a decent grasp of math, otherwise you won't be able to count what you're doing.
And then we pretty much use measurements every day in life as pretty much just looking in front of you, you can see peripheral vision, basically how much what you can see from the corner of your eye. And a healthy peripheral vision would be like 170 degrees, or depending on how far you can see. Obviously, as we see, the bunny can see all around. And I think it's interesting because it's like it's pretty much math too. You could even make a protractor at home, so you could like measure yourself and your family and see how much you can see, like what measurements you can see from the corner of your eye. Also in baking and cooking, you know, we use math in that as well to calculate what we need for like certain ingredients, or like how much you're making. And you know, when you bake something, you definitely need to put a timer on, and it involves numbers as well. And that's it. How do I stop sharing?
If you go on the bottom, you can put stop sharing, I think.
What?
Oh, there you go. All righty. My son was watching the presentation as well. Did you learn a lot? Did you learn about that?
I heard some.
You heard some of it? Right.
You should definitely do the peripheral vision measure thing. It's pretty fun.
Cool, cool. All right, well, thank you both groups for presenting about how math is used in everyday life. Moving forward, group 4 and onwards is gonna keep going forward. Remember, you can share anything that's math related. If any of you guys wanna do anything about coronavirus, there's a lot of mathematics that can be talked about in that as well. Or you could talk about a review. You could review any topics that we've done, and you might wanna do an exam review, for example, for those who are going to be presenting next week, or a quiz review on topics that we've already done. So whatever floats your boat, there's lots of ideas that you guys could use for presentation. All righty, thank you everyone. Now we're going to continue to move forward with looking at the example that I just had you guys do during the break. And if you didn't do the example during the break, that's fine. But I'm going to show you a video of how to solve it, and you can compare it with what you guys had. So I'm going to share a screen right now.
I used to share a screen.
Yep, I'm going to share screen. Hold on. Can you guys see that?
Yes.
Yes.
Yeah, okay. The one that's, so I'm going to click on this. Can you guys see this video?
Yes, we can.
Okay. Hi, this is Professor Nancy Mahan. I'm going to be doing another video on complex rationals, and it is pertaining to this question here. So as you can see, it's a fraction over another fraction. Okay. And this one's a little bit harder than the previous one we did, so let's take a look at this. So if you recall here, I had 3 steps. Step 1 is find the lowest common denominator. And what we do with the lowest common denominator is we get rid of small fractions by multiplying the numerator by the denominator. And by multiplying the numerator and denominator by the lowest common denominator, and then we simplify the fraction. So this was in the previous video, so let's take a look at this problem here. We're going to follow those same exact steps. So the step 1, again, is to find the LCD. So find the lowest common denominator of, so I'm looking at the top here and the bottom here. So the lowest common denominator I was v plus 8, v minus 2, v plus 8, v minus 2. Those are the denominators. And if you recall in one of the other videos, to find the lowest common denominator, it is also the product of unique factors in the denominator. So here, these are the factors in the denominator. So they're all already factors. So I actually don't have to do much work with that. In this case, I'm going to see that the LCD is going to be the product of unique factors. So this is a factor, v plus 8. This is a factor, v minus 2. So it's the product of it, right? So I put it right next to each other. And let's see v plus 8 again. But guess what? Is that unique? No, unique means that it's one, it's it stands by itself, right? There's not another copy of it. So there's already a v plus 8 here, so I'm not going to write it again. And then v minus 2. Well, v minus 2 already occurred here, so I don't have to write it again. So that is my LCD. So once I find the LCD, step 2, I'm going to multiply everything by the LCD. And why do I do that? It'll get rid of the little fractions, quote unquote little fractions, right? So these are the little fractions, right? Because there's a big fraction here, but then there's these little fractions. So I'm going to multiply everything by v plus 8 times v minus 2. So here I'm going to multiply this, v plus 8, v minus 2 on top, v plus 8, v minus 2, v plus 8, v minus 2, v plus 8, v minus 2. And look what happens. What should happen is that the little fractions should disappear. So in this one here, the v plus 8 divided by v plus 8, right? These are both factors. They can cancel out and just becomes a 1. So what's left on top? 6 times v minus 2. So 6 times v minus 2 for this one, minus, in this fraction, guess what cancels out? The v minus 2 cancels out, and I'm just left with 1. So I have minus, and then v plus 8. And what did I do wrong? I did not put the parentheses. So make sure if you have a minus here, you put parentheses after whatever goes after it so that you can remind yourself that you need to distribute. Divided by this denominator here, v plus 8 cancels out. So I'm left with 3 times v minus 2. Plus, what cancels out? V minus 2 and v minus 2. So I'm left with 2 times v plus 8. So once I do that, now I am at step 3, where it's basically simplify. Right? Simplify this problem. So I have all these parentheses, so I'm going to distribute through to get rid of the parentheses. I end up getting 6v minus 12. I distribute through here. Good thing I remember to put the parentheses. I put minus v minus 8. In the denominator, distribute through 3v minus 6 plus distribute through 2v plus 16. Some of you guys might be tempted before we do all this to start canceling things out already. You're like, oh, v minus 2, cancel, v plus 8, cancel, 6 divided by 3, cancel. Please do not do that. Remember, the only thing that you can cancel or cross out or divide out are factors. These are not factors yet. This is a polynomial that has not been factored yet. Polynomial that has not been factored. So please, please do not cancel things out up and down like that. So we need to simplify it. And after we simplify it, if we can factor it, then we can cancel out. So even though I'm saying that, I know a lot of you guys might still do that in a test because I see that all day, all night long. So now when I look at the top, I'm going to simplify. 6v minus v will give me 5v. Negative 12 minus 8 gives me negative 20. 3v plus 2v gives me 5v. Negative 6 plus 16 gives me positive 10. I'm just going to double check my work real quick because I tend to make some adding and subtracting errors just to make sure I do it right. Okay, so now that I have that, and again, please do not just cancel things out here because it's not factored yet. Now the numerator is simplified, the denominator is simplified. Now I'm going to factor. So once I factor it, then I can cancel things out. So here at the top, I can factor out of 5. Inside, I have v minus 4. The bottom, I can factor out of 5. Inside, I have v plus 2. So now that it's all factored, I factor, 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 factor. What can I divide out or cancel out? The 5s can cancel out, right? Those are common factors. The v minus 4 and v plus 2, please do not cancel this out because v minus 4 is stuck together as one factor. That's like the head and the body. The head and the body. Do not amputate the head and the body, please. So here, as a result, I end up getting v minus 4 over v plus 2. And that, my friends, is the final answer of simplifying something very complex to making it look very, very pretty. Alrighty. Where is this? Sorry guys, I'm trying to find out where my screen is at right now. Wait, stop share. All right, does anyone have any questions on complex fractions? We've done 2 of them already. Sorry, give me 1 second. 1 second. You guys, I need you to go outside right now. Seriously, Sawyer, go outside. I know, thank you for helping. Go outside. Mommy's still working right now. Okay, let's be quiet, okay? If you guys are saying it, let's be quiet. Be careful of this, this might fall. Okay, I'm really sorry, guys. Okay, so next, you guys, seriously move.
Why?
Because I'm still working right now. All right, so next we're gonna talk about equations. So we have 10 minutes left. Sorry, we didn't get much of a chance to practice the complex, but then you could practice that in Alex. We're gonna talk about equations now, and this is basically the meat of rationals. Like everything in the end is we wanna solve equations. So I'm gonna show you guys a video on number 23. So go ahead and take out number 23, right there. And I'm gonna show you a video on how do you solve equations. And the nice thing about solving equations is it's exactly the same steps as solving complex. Meaning you find the LCD, and then you multiply everything by the LCD to get rid of the fractions, and then you continue forward. So sorry, there's a monkey on my back. All right, let's go ahead and share screen. Is that ours? Nope, that's not good. Hi everyone, this is Professor Nancy Mahan. In this section, we are going to be talking about solving rational equations. So here we have an equal sign, so that's what makes it an equation, and rational, meaning you have these crazy looking fractions in the equation. So I just want to review what we've been doing thus far in this chapter. We've learned how to simplify rationals. We learned how to multiply and divide rationals, and we've learned how to add and subtract rationals. And we know when we add or subtract rationals, you need a lowest common denominator. Also, before this, we also learned how to deal with complex rationals. So we've learned to do a lot with this thing called rationals. So now it all climaxes to solving an equation with rationals, which is the reason why we learn about rationals, because there's lots of things in real life that when you create an equation to model it, it ends up having these types of fractions in it. So the steps to solve a rational equation is exactly or very similar to the steps to simplify a complex expression. Sorry, not the coronavirus, I just choked on myself. So here, complex rationals, if you remember in the previous video, first thing you do is find the lowest common denominator, and then you multiply everything by the lowest common denominator in order to get rid of the fractions. So same idea here. I'm going to, step 1, I'm going to find the lowest common denominator. So the lowest common denominator here, so this is, if I wanted to write this as a fraction, it's 1 over 1, right? So I look at the denominators and I say, okay, what's the lowest common denominator? Well, these are polynomials. So with polynomials, it's not as easy to find the lowest common denominator. So we realize and we remember that the lowest common denominator is the product of unique factors in the denominator. I hope I'm sounding like a broken record. Product of unique factors in the denominator. So here, what are the unique factors in the denominator? Well, 2u plus 12, first I gotta factor it, right? Because it says unique factors. What's the factors of 2u plus 12? It's gonna be 2 times u plus 6. What are the factors of 1? Just 1. What's the factor of u plus 6? Just u plus 6. So what is the LCD in this problem? The LCD is the product of unique factors. So 2 is a factor, u plus 6 is a factor, so I write it as a product. 1 is just 1, u plus 6 is another factor, but it's not unique. It's already written here, so I don't have to write it again. So once I have the LCD, step 2, I am going to multiply both sides of the equation by the LCD. And why do we do that? In order to get rid of fractions. So again, it's the same story as we've done before in terms of equations with fractions. We want to get rid of the fractions. So here I have -1 over 2 times u plus 6 plus 1 over 1 is equal to -7 over u plus 6, right? So I just rewrote the 2u plus 12 as 2 times u plus 6. So now I'm going to multiply everything by the LCD, 2 times u plus 6. So I'm going to put multiplied by 2 times u plus 6, multiplied by 2 times u plus 6, multiplied by 2 times u plus 6. And look what's going to happen. In the first fraction here, what cancels out? The u plus 6 plus the u plus 6, if you divide it by each other, you end up just getting 1. A 2 and a 2, if you divide it by each other, you end up getting 1. So what's left? Just -1. Plus, in this one here, nothing cancels out with the denominator, so all you do is you have 2 times u plus 6. 1 times 2 is 2, right? So 2 times u plus 6, so I'm just going to go ahead and multiply that through. I get 2u plus 12 is equal to, the right side, what cancels out? U plus 6 cancels out and just becomes a 1. They divide out. So what's left over? -7 times 2, which is -14. Holy smokers, this is so beautiful, right? So, so beautiful. No more fractions. Last but not least, go ahead and solve for your variable. So this is a linear equation. So in my mind, I'm thinking, okay, this is a linear equation. So linear equation, because I know the highest exponent is 1. If it was a quadratic equation, if the highest exponent was 2, then I'll have to set the equation equal to 0. But since this is a linear, I go back to what we did in the first day of class, which is we simplify the left side. So 2u, the -1 plus 12 combines together to give me plus 11 is equal to -14. I want the u to be sitting by itself, so I say that I want the u to be on the left side. So if I want u to be sitting by itself, I'm going to subtract 11 on both sides. I end up getting 2u is equal to -25. I want u to be sitting by itself again, so I divide by the coefficient, the number that's attached to the u, that's multiplied to the u, that's a coefficient. I divide both sides by 2. That becomes a 1, and therefore my answer is u is equal to -25 over 2. Okay, and last step is step 4. Step 4 is to make sure, so check your answer. So make sure we do not want to have a number divided by 0. Remember, the domain of a rational expression or a fraction is that you can never have a 0 in the denominator. Just plugging in -25 over 2 into my original problem make it become a 0 in the denominator. Well, let's take a look. If I put 2 times -25 over 2 plus 16, I'm sorry, plus 12. If I do that, the 2's cancels out. I have -25 plus 12. Okay, that does not give me 0, so I'm okay with that. If I plug in -25 over 2 into here, negative 25 over 2 plus 6, that will not give me 0. So I'm A-okay. So I checked my answer to make sure that my answer is indeed in the domain of this problem. Then when I plug it into the original problem, I don't create a 0 in the denominator. You will get some problems where you get some answers, but when you plug it into the original equation, you're going to get a 0 in the denominator. And if that's the case, then you omit that answer. But in this case, this is A-okay. Alrighty, any questions on solving equations with complex or with rationals?
I have a question.
Yes.
For number 17, I don't understand how to do it.
Number 17, okay.
Yeah.
So real quick, so I'm gonna get to your question, Margot.
Okay.
Real quick, it's about almost 3:30, so I want to honor everybody's time. So for those of you guys that need to leave at 3:30, feel free to do so. Thank you for showing up. Remember, Garrett has office hours until 4 o'clock on Monday through Thursday. Our next Zoom session will be on Monday. And remember that you guys have a quiz coming up as well on Monday and homework due on Thursday and Sunday. So please make sure you're checking your emails, checking the Facebook, whatnot. And if you need to contact me or Garrett for any reason, feel free to do so. So this time, any of you guys want to leave, feel free to do so. I'm gonna stay here and answer any questions that you guys have, okay? All right, so Margot, let me go ahead and pull this up.
Okay.
It doesn't fall on me. Sorry, today's kind of crazy. I have my kids, so yeah, just craziness. Love them to death. You said number 17, right, Margot?
Yeah.
Okay. Okay, so Margot, if you don't mind, why don't we do this together?
Okay.
All right, so looking at this problem, the first thing you want to do is find the lowest common denominator. What do you see as the lowest common denominator? What denominators do you see, first of all?
Oh, 2u.
Okay, 2u and 2u, right?
Yeah.
So what do you think the lowest common denominator would be?
Would be 2.
2 what?
2u.
2u, right. So next, we're going to multiply. Okay, that was the third time today. Oh my gosh, hold on 1 second. All right, I feel it's gonna happen several times today, so please bear with me. So you're gonna multiply everything by 2u, right? So first of all, 5, to rewrite 5, you could rewrite the 5 as 5 over 1. So the 5, just to make it clear that it's also a fraction, you can write as 5 over 1.
Mm-hmm.
And the 3, you could also write the 3 as 3 over 1, just to make it sure which one's the denominator and which one's the numerator, right?
Yeah.
Okay, so we're going to multiply everything by 2u. So 2u, 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 and 2u. Okay, so if we do that, Margot, what would happen to this first fraction?
2 times would be 10u.
Right, 10u. Great. Minus what? The second fraction, what cancels out?
The 2u on the bottom on the top.
Right. And if it cancels out, it gets replaced with a 1, right?
Yeah.
You get minus
1u. Or just u or 1.
Actually, the 2 canceled out to get 1, and the u's also canceled out as well, right?
So then it would just be 1.
Good, good. And then the bottom, what do you get with the first fraction?
Would be 6u.
Perfect. 6u plus, what do you get? And what cancels out in the second fraction?
The 2u's.
Okay, 2u's cancel. So you end up with plus
1.
Plus 1. Great. So I'm going to ask you, can I cancel out the u's here or the 1's here?
No.
No. And why not?
Because 10u and 6u doesn't cross out, and then the -1 and +1 don't really cross out. They're not the same.
Right. Technically speaking, this is a factor and this is a factor.
Okay.
Unless we can factor it, so unless we can factor these problems, we can't really cross anything out, right? So therefore, that becomes your answer: 10u minus 1 over 6u plus 1.
Oh, okay.
Is that okay?
Yeah, that makes sense now.
All right. Good question, Margot.
Thank you.
Anyone else have any questions at all? I'm here to help. The equations, I did numbers 21 to 26. I mean, on here, this is problems number 21 to 26. I only did one of them on video, which was number 23. If you guys want me to do any others, let me know. And then there are 3 word problems, which I actually didn't get to. I'll probably make a video on those. So there's 3 word problems.
When do you think you'll put the word problem video up? Like later today or tomorrow?
Yeah, when my kids are asleep.
Oh, okay.
Hopefully today. I'll try to do it today because I know this part is due on Sunday for you guys.
Yeah.
And if you don't hear from me, feel free to remind me. Sophia, see, you asked a question. You said, can you do number 22? I sure can. 22. Okay, so let's look at Sophia's question, number 22. I think when things dropped, like everything dropped with it. Can't find my eraser. All right. All right, so I'll just do it on the side. Can't find my eraser. Sorry, I'm so ghetto. Let's see. Can't even find a paper to erase things with. All right, I'm gonna use a very valuable toilet paper tissue. All right. All right, so number 22 is an equation that Sophia's asking. All right, so 1 over w plus 1 is equal to -4. Let's go closer to you guys. So this problem could actually be done 2 ways. One way is that I noticed it's a fraction equal to another fraction. So because it's a fraction equal to another fraction, technically speaking, I could see this as a proportion and I could cross multiply. So here, if I see this as a proportion, I say 1 over w plus 1 is equal to -4 over 1. It's a fraction equal to a fraction, proportion. We learned this in one of our earlier chapters. So if something's in a proportion, you could actually cross multiply if you want the shortcut version. So the shortcut version is you could cross multiply. 1 times 1 is 1. Cross multiply -4 times w plus 1. Okay, to get rid of the fractions. So we're left with 1 is equal to -4w minus 4. And here I'm going to solve for w. W is a linear equation. Here's the highest exponent is 1. So I'm going to think to myself that I want my w on the right-hand side. So because I want the w on the right-hand side, I'm going to add 4 to both sides. So I end up getting 5 is equal to -4w. I want w to be sitting by itself, so I divide by the coefficient -4. So -4 divided by -4 just gives me 1. So therefore w is equal to -5 over 4. And that would be my answer. And I could double check by plugging in -5 or 4 into the equation to make sure that I don't get a 0 in the denominator. So -5 plus 1 will not give me a 0 in the denominator. So this answer is A-OK. The other way of looking at this problem, if you didn't see as a proportion, is to do it the way that we've been doing earlier, which is multiply everything by the LCD. So here, -4, you could rewrite this as -4 over 1 again. And if you ask yourself, what is the LCD? of this problem, well, the LCD, if you look at the denominators, the LCD is just W plus 1, right? W plus 1 times 1, which is just W plus 1. If I multiply everything by W plus 1, look what happens. If I multiply everything by W plus 1 cancels here, so I'm just left with a 1, is equal to W plus 1 here times the negative 4 times W plus 1. And what do you know? It's exactly the same thing as this, right? So it's the same thing as that, and then you end up just doing the same thing. So again, you can look at it as a proportion where you cross multiply, and a proportion is only when you have a fraction equal to a fraction. Or you can look at it as what is the LCD and multiply everything by that to get rid of the fraction. Okay. Is that okay, Sophia? Okay, I see your thank you. Great. Anyone else have any other questions on this? And if you want me to do a word problem while I have you guys on, I could do that too.
Do you think you could do number 14?
Number 14, is that Ashley?
Yeah.
14, I sure can. So, all right, so number 14 is another complex fraction, and it looks complicated and ugly and scary, but if we stay calm, it'll be a-okay. That's the top fraction, and I kind of like doing 2 different colors just so I could easily see what's going on. Who says math has to be done in 1 color, right? All right, so Ashley, I'm gonna have you help me out if you don't mind. You on?
Yeah.
Okay, so Ashley, so the first thing we're gonna do is we're gonna look for the lowest common denominator. So I'm gonna look here, denominator, denominator. So what is the LCD when you look at this? So let's look at 21 and 7. Let's look at the numbers. What's the lowest common denominator of 7 and 21?
21.
Good, so 21, we think of the lowest common multiple. Right, the multiple that they have in common is 21.
Mm-hmm.
And then I have A, and there's nothing here. So do I put an A for LCD?
Yeah.
Yes, right, because again, we're thinking lowest common denominator is the product of unique factors. And that B5 and B3, what's the lowest common multiple of B3 and B5?
B5.
Good. Great. Everyone okay with that? All right, great. So I'm going to multiply everything by that. So I'm going to multiply by 21AB5, oops, times 21AB5. So what should happen when we do this is that the denominators will cancel out. So let's take a look at the top. I dropped, oh, here it is. So let's look at the top here, out of ink. So looking at this, what cancels out, Ashley?
I'm sorry, what happened?
So so looking at this top here, what cancels out?
Nothing.
So try again. So I have this fraction multiplied by the LCD. So something should cancel out if we're doing this right. So here's
the 21.
Good, the 21s cancel out. What else cancels out?
The B5.
Good, the B5 cancels out. Right? So as a result, what we should have then, what should we have left on top?
5C.
5C.
To the 4th. And A. Well, D4 and then A.
D4 and then A. Great. Good. Everyone okay with that? All right, let's look at the bottom. What cancels out on the bottom?
A.
Okay, the A's cancels out. Good.
And I think that's it.
So try again. The 21 and the 7. Do these cancel out?
Yeah.
What does it become?
3.
Yes. 21 divided by 7 becomes 3. Good. How about the B5 and the B3?
It would be B2.
Good. So B5 and B3 cancels out, and this becomes B2, right? So again, if anyone was wondering, B5 would be 3. Quotient rule, 5 minus 3, you get 2. Great. So you get B2. So what is left on the bottom?
Where?
So what's left on the bottom, Ashley?
Oh, 10, C3.
10, C3.
D.
D.
And B2.
And B2. And what else?
The 3.
Yeah, and the 3. You can multiply in the 3 here, right? So we can simplify the bottom a little bit more, right?
Yeah.
So the bottom would become
30.
30.
Oh, sorry.
So 30 C3D B squared, right? Are you okay with that so far? All right, so now that we have this fraction, am I done?
No.
No, right? I can simplify. So like every time you're almost done with something, you say, can I simplify it more? What can I cancel out or what can I simplify?
The 5 and the 30.
Right, the 5 and the 30, they're both divisible by?
5.
5, so 5 divided by 5 is 1, 30 divided by 5 is?
6.
6, great. What else can I simplify?
Would you be using the quotient rule for this one?
Yep.
So it would be C.
C, right. So I have a C4 and a C3. C4 divided by C3, the quotient rule, we subtract, you get C to the first power, or just C, right? Okay, so let me just start writing this out. I have 1 over 6. I have a C. C goes on top. What else simplifies?
D.
Okay, so I have a D4 and D.
So
it'll become a what?
D3.
D3, great, because you subtract the exponents. So you get D3 on top. And what else?
And I think that's all. But you would keep the A on the top and B squared on the bottom.
Perfect. Yeah. And I don't need to put 1 because 1 is just kind of redundant. So this becomes your final answer. You did it. Good job. All right. Does anyone else have any other questions?
Can you actually do word problem number 27?
Word problem number 27?
Yeah.
Sure. Number 27. Okay, let me go ahead and erase this. All right, 27. Okay, so Anne drove 327. So Anne drove 320 miles using 12 gallons of gas. Okay, how many gallons would she need to? How many gallons of gas would she need to drive 296 miles? Great. So this is what something is. This setup is something that we would consider a proportion. So a proportion. Sorry. So here a proportion is I'm comparing two things, right? But it's the same car, the same person driving the car. So the first scenario. So I'm going to create a proportion. So proportion again is a fraction equal to another fraction. So I'm going to be comparing two things that are proportional to each other because it's the same car using that therefore uses the same amount of mileage per gallons per mile. So the first scenario, so here's the first scenario, is proportional to the second scenario. So the first scenario is that she drove 320 miles and 320 miles and she used 12 gallons. So I'm going to write it as a fraction. So in 320 miles, she drove, and for 320 miles, she used 12 gallons of gas. This is equal then to how many gallons So here, we want to know how many gallons. I'm going to put X because the bottom part has gallons, right? So the denominator here is gallons, and the numerator here is miles. You could have flipped it around as well. It doesn't matter the order, just as long as the miles are always on top or the gallons are always on the bottom, or vice versa, gallons are always on top and miles are always on the bottom. So it doesn't matter where you put which, as long as you keep it consistent. So the numerator is the miles. So here, how many gallons? I call that X. How many gallons? I call that X to drive 296 miles. Right? So this is called a proportion that compares two different scenarios in which the car uses the same mileage, right? The same miles per gallon. So that's why it's equal to each other. So here, I see it's a fraction equal to a fraction. So I'm gonna make my life easier and I'm gonna use proportions to solve this. Meaning I'm just gonna cross multiply. Instead of having to do the LCD or whatnot, since it's a fraction equal to a fraction, I can cross multiply. So proportions, you can cross multiply. So when I cross multiply, 320 times X gives me 320X is equal to, if you have a calculator, I don't have one on hand. I don't even know where my phone is. 296 times 12. Anyone have a calculator? What's 296 times 12?
I got 3552.
3552, like this?
Yeah.
Okay. Great, thank you, Marco. So 320X is equal to 3552. I'm gonna divide both sides by 320. So when you divide both sides by 320, what do you end up getting for X?
11.1.
11.1, right? And it's 11.1 what?
Gallons.
Gallons? Yeah, gallons, right? So here to drive to drive 296 miles, she's going to be using 11.1 gallons. And let me just double check this on number 27 in the back. Was that right?
Yeah, 27.
Okay, perfect. 11.1 gallons. Perfect. Does that make sense?
Yeah, that makes sense now.
Great, great. Anyone else have any other questions? I probably have time for one more.
Is that the same thing you would do for all the problems? Or
No,
what if you-
all of the 28 and 29 are different. Do you want me to do one of them?
Yeah.
Anyone you want in particular, Ashley?
It doesn't matter.
All right. I think this board is about to collapse any minute. All right. So 28 is a work problem. So it's working together. And the 29 is a motion problem. It's about someone rowing a boat. So, okay, maybe that's better. No, it's not. I don't mind. 1 second. Hold on, guys, I'm almost done. 5 more minutes, I'm almost done. All right, so here, I think I'll do okay, read it. I think I will do number 28, since you guys haven't seen a problem like 28 yet. So 28 here says, working together, it takes 2 computers 5 minutes to send out a company's email. If it takes a slower computer 15 minutes to do the job, how long will it take a faster computer to do the job on its own? So this is called a work problem. And we have not seen a word problem like this until this section. So work problem is basically talking about when 2 things do the same job. And as we know, if 2 things do the same job, they should usually work a lot faster. So when they do the same job, how does that change the work? How does it change the rate in which something is being completed? So here, the work problem, the formula is actually really simple. It's the job done divided by the time it took to complete it, time completion, right? And in this case, since we're dealing with more than one person working on a job or more than one thing, say a computer or whatnot, so if job done by the first person and the time that took that first person to do it, or thing, in this case, a computer, plus the job done by the second person divided by the time it took the second person to do it is equal to the job done together divided by the time that it took to do the work together. So for an example, if I wanted to hire someone to paint my house, and I hired someone, the first guy, he said he could paint my house in, say, 5 days. And I said, sorry, dude, I need this house painted in 3 days because I have people coming over for a party. So he needs to find someone, since he could do the job in 5 days, he needs to find someone that can do it at a certain amount of time, maybe at a faster speed than him or slower speed than him, to work together with him so that together they will get the job done in 3 days. So that's the idea of this formula. So in ALEKS now, not in all classes, but in ALEKS, the problems in ALEKS, the job done is always going to be the same. It's going to be painting the same house. Everyone's considered painting the same house or working on the same job. So because it's always the same house or the same job, since they're always going to be the same, we're just going to put the number 1 instead. So here we're going to put 1 over time of the first person to get it done plus 1 over the time of the second person to get it done is equal to 1 over time together. And this is the big kahuna formula that you need to know for a problem like number 28, a work problem. So again, the number 1 represents that they're all doing the same job. They're not doing different jobs. In Math 45, I think Garrett's teaching that class, I think you'll see this where the jobs done might be a little bit different. So instead of putting 1, you would describe what that job was. So in this problem here, working together, it takes 2 computers, 5 minutes to send out a company's email. So here you go. So the time together is 5 minutes. So they're giving you that the time together is 5 minutes. So I'm going to erase the time together here, and I'm going to put the number 5. Because it said working together, it takes 2 computers 5 minutes to complete the job. And then you keep reading it, it says, if it takes a slower computer 15 minutes to do the job on its own, so the time of the first computer is the time of the slower computer. So it tells us that the time of the slower computer is 15 minutes to do the job. So 1 over 15 minutes. So the slower computer took 15 minutes. So the faster computer, how long will it take the faster computer to do the job on its own? So here, the faster computer, I'll just call that X, right? So I'm gonna let X equal to the time of the faster computer, right? So it took the slow computer 15 minutes, took the fast computer so much time, but together they get it done in 5 minutes. So what is X? So that's the hardest part of the problem, to interpret it and create an equation. Any questions on that? No questions? All right, so let's go ahead and solve this. So when I solve this, I have 1 over 15 plus 1 over X is equal to 1 over 5. Well, what do you know? 1 over 5. What do you know? This is a rational equation. It has fractions in it. So how do I solve a rational equation? I find the lowest common denominator and I get rid of the fractions. So I have 15, X, and 5. The LCD is going to be, anyone know what the LCD is going to be?
15.
15, all right. So the LCD is 15 what? We're missing one more thing.
X.
X, right. So X, because the lowest common denominator is the product of unique factors in the denominator. 15 and 5, 15 is the lowest common multiple, and then X is also a factor, so you need to put it right there. So if I multiply everything by 15X, what should happen is that the denominators should be divided out. So if I do that, the first fraction here, what cancels out? The 15s cancel out, right? So I'm left off with 1 times x, which is just x. The second fraction, what cancels out? Just the x, so I'm just left with 15. And then the last fraction, what cancels out? The 15 and the 5, so I'm left with 3. So I'm left with equals to 3x. So now I solve for x. I'm going to subtract x on both sides. I end up getting 15 is equal to 2x, right? So this is 2x, this is 15. 15 is equal to 2x. I divide both sides by 2. Sorry, my writing's getting ugly and uglier. So I end up getting that x is equal to 15 over 2. Well, when we think of this word problem, they're asking us how long does it take us for the faster computer to do the work. You don't really answer someone when they ask you how long. You don't say 15 over 2. You give it in terms of a decimal. So you would say that this is 7.5. Right? So here, the faster computer takes 7.5 minutes to complete the job. And it should make sense. The slower computer takes 15 minutes. So the faster computer should be less time, right? So 7.5 minutes. Together, they work together. If you check your work, you'll find out that they finish a job together in 5 minutes. And this is what we call a work problem. The last word problem in number 29 is a motion problem, which you guys are very familiar with. The motion problem we've done before. So nothing changes with the word problem. We've seen these before. However, you're going to end up setting it up where you're going to end up finding fractions in your problem. So to solve this problem, you're going to have to use the things that you learned about solving rational equations. Okay. So if you guys have questions, feel free to ask me or Garrett when the problem comes up. Alrighty, any other questions? If not, I'm gonna call it a day. So feel free again to let me know if you guys have any questions. Otherwise, I'll see you guys again on Monday, if not earlier. Right.
Have a good one.
Take care. Thanks, everyone. Thank you, Joseph. Bye. Bye, Sophia. Bye, everyone.
Have a good one. Bye.
Bye, Garrett.